Hello and welcome back. Today we'll begin discussing factors that can result in flooding, flash floods, and coastal flooding. Floods can have varying effects depending on how and where they occur. Upstream floods, which only affect small localized areas, typically are caused by sudden rainfall or dam failure. Downstream floods, which affect a larger area, result of prolonged rainfall and extensive snow melting. In 2019, the United States experienced tremendous flooding within the Midwest and the South, which affected over 14 million people and caused an estimated $6.2 billion in damages. Floodwaters completely devastated farmlands and towns along the Mississippi River, and residential areas became unrecognizable. Factors that can cause flooding are rain, river overflow, available drainage, lakes and coastal flooding, dam breakages, and glacial melting. I will go into detail about each of these factors and the role that they play. Rain is a leading cause of most flooding across the world. Depending on the intensity and duration of the rainfall, it can lead to flooding. Both intense downpours and light rain can lead to flooding events. Rivers can overflow their banks as a result of exceeding their holding capacity. This can result in flooding into floodplains, which are the areas adjacent to the river that are subjected to flooding. As you might be thinking, there are consequences for developing on floodplains. In some cases, this could be due to ignorance and not realizing you have built in an area that could experience high flooding. One result of building in areas that are prone to flooding is the increase of asphalt and non-porous construction material, which results in loss of natural drainage that comes from vegetation. Construction material is impermeable and does not allow water to seep into the soil, whereas a very porous and permeable soil allows water to sink into it. However, the soil can also become saturated and result in flooding. Lakes and coastal flooding can be resulted of tsunamis or large storms causing the water to surge inland. These surges can have catastrophic results since they can be extremely powerful and can destroy houses, bridges, and more. In addition, hurricanes can also cause coastal waters to surge into dry lands, causing flooding of those areas. Dams are man-made structures and have had detrimental impact on the ecosystem. In addition, since these dams are holding massive quantities of water, the erected walls can become weak and in some cases can break, causing flooding in the adjacent areas. Lastly, another factor that can result in flooding are the melting of glaciers and snow. During the colder months, ice and snow forms on the tops of the mountains. As temperatures begin to rise, it results in accumulated snow and ice melting. This can produce massive movements of water and can overwhelm streams, causing them to overflow. You can plot stream fluctuations over time, and this is known as a hydrograph, which can be extremely useful, especially if there is sufficient data over a prolonged period of time. A hydrograph plots both precipitation and the stream's discharge. A stream's discharge can fluctuate over time and be affected by rainfall, snow melt, dams, and more. You can have hydrographs for a short period of time or over a prolonged period of time. These graphs give a better picture of normal behavior of a stream and also might indicate when a flooding event might occur. When looking at these graphs, there are a few things to point out. The red line shows the stream's discharge and the bar graph in blue shows precipitation over time. The lag time is the difference between the peak rainfall and the peak discharge. The lag time indicates how long it takes for the precipitation to enter the river. The longer the lag time, the longer it takes for the rainfall to enter the river, whereas a short lag time indicates that rainfall is entering the stream rapidly. The rising limb is the steep climb of the discharge curve and shows that the rate of flow is increasing. The falling limb shows when the stream's discharge is decreasing. A number of factors that can affect a hydrograph, such as amount of non-porous impermeable rocks, weather and climate, and vegetation cover. If you have non-porous material near a stream, this will not allow water to permeate and can cause a high peak discharge and a short lag time, which results in the river overflowing more easily. In contrast, if you have more vegetation around the stream, this allows for rainfall to seep into the vegetation and increase the lag time and decrease the peak discharge as a result. In addition, increased storms and rainfall will also impact the peak discharge and lag time depending on the intensity and duration of the storm. In more recent years, the effect of global climate change has made it more difficult to predict the hydrology of a stream. This can make it more difficult to predict flooding events and greater peak discharge in some water systems. Keeping this in mind, it is important to consider how anthropogenic influences can affect natural water systems. Thank you, and I hope the rest of your day goes swimmingly.
1, 2, 3. Cheese.